Well, hi again, it's Bob, and we're getting ready to take a look at what I'm calling 7.2 Part 2. Hopefully you've had a chance to make sure you can use the chi-squared tables. I mentioned that homework question number 3 had 5 of those. I'm on the top of page 402, and I'm hoping my pen doesn't start bleeding ink here on the screen. But they tell us that we need the assumptions for finding a confidence interval for a variance or standard deviation. And there's 2 assumptions. One, that it's a random sample. That sounds familiar. And that the population must be normally distributed. So our sample then is both random and comes from a population that's normally distributed. And I'm just going to go look at these. I'll leave the rounding rules for you, but I want to go look at these 2 examples. And the first one was example 714, dealing with osteoporosis. And it talks about a sample of 30 women. And recall, whenever I get a piece of information, I like to write it down. Had a standard deviation of age of 5.2. Now, notice that's the standard deviation, and as I mentioned, when we get into the formula, on the numerator of our formula, it calls for the sample variance. So just be on the lookout that we're going to have to square that at some point in time. And we want the 95th confidence interval. We want to be 95% sure of our answer. I'll use CI for confidence interval. And they tell us here that the variable is normally distributed. Okay, well, we'll go to work on the important things in just a second, but I want to again write that formula. Get my pen back here. This is on the left side, n minus 1 times the sample variance. That's, or I could say the standard deviation, sample standard deviation squared. And notice that we have chi-squared right on the left side of the formula. You can always write the formula down and refer to it. And then, of course, we have our population variance, which we're setting up an interval for. And on the right, we have n minus 1 times the sample variance, or population standard deviation squared, divided by our chi-squared left value. Okay, well, let's go to work first. I'll just go ahead and put what we know. We had n equals 30, so our degrees of freedom will equal 29. That's the value we're going to go into the table with. And we want the 95th confidence interval, so let's carefully go through that. So this would be, to find our alpha, it would equal 1 minus 0.95. So our alpha would equal 0.05. But with the chi-square tables, we must cut that alpha in 2. And it equals, lost my pen again, 0.025. Now, remember, in order for us to get into the table, we got one more thing to do. That 0.025 will be on the right side of the table, but we need to find its complement on the left side, and we do that by taking 1 minus 0.025, and that gives us 0.975. So keep in mind, and I'll write a stylized version of this, it's just the values that we need here. If this represents our, our chi-square tables, and I hope I didn't goof that up earlier, we want 0.025 and 0.975. Okay, and this would be like our values for alpha here. And our degrees of freedom were 29. That's such a mess, I'll just leave it out. And when we go down, our chi-squared right value, they tell us is 40, excuse me, I've lost my place here. I don't have a transparency, but hopefully you'll go back and see that the chi-squared right value is 45.722. And the chi-squared left value should be 16.047. Now we have everything we need to go into the formula, but just recall that they gave us a standard deviation of 5.2 years, but that has to be squared because the formula calls for the variance. And so when we put this into the formula, we're going to have to put it in this way. Or I guess you could just square 5.2, but I'm pointing out the way the book wants us to think about this. So this is how we end up with our formula of 30 minus 1. I could have just written 29, but we're doing everything kind of by the book here. And I've already mentioned why we need to square the 5.2. Okay, and recall that our chi-squared right value goes on the left side of the equation, so we have 45.722, and on the right we end up with 16.047, which we explained recently. So we can be 95% confident of the variance falling in between 48.9 and 17.2. But remember, we're more interested in the standard deviation. So what we do, recall that the square of the variances gives us a standard deviation. In this case, of course, the population standard deviation, and that lies between 4.1 and 7.0. Well, remember, our sample standard deviation was 5.2. Okay, so what we've done is we've added a little bit to 5.2 and we've subtracted a little bit from 5.2 to set up our 95% confidence interval. That's our 95% confidence level, which gives us the values for our 95% confidence interval. Okay, well, there's only one other one to look at here, and this is at the bottom of page 402, and it's example 715. And it has to do with named storms. And we have a, 4, 6, 8, 10, we have a sample size of 10. It says find the 90th confidence interval for the variance and standard deviation for the number of named storms per year in the Atlantic Basin. And we have a random sample of 10. So right away we know degrees of freedom equal 9. And notice that in this case, they tell us that they give us the raw data, and we would have to go back and do the rather lengthy calculation for standard deviation of a sample that we learned in chapter 3. Okay, but I'm going to take the book's word for it, and they tell us, and this time we know the variance is 16.9. Recall that our formula asked for the variance. Okay, so this time we do not have to square 16.9, it is the variance. Okay, and so if I'll quickly go through what we would need to do to find we want the 90th confidence interval on this. So as you might recall, to find our alpha, it equals 1 minus 0.90. So alpha equals 0.10. Then we need to cut that in half, find alpha over 2. Now, we're not done yet. The last thing we need to do is subtract that 0.05 from 1 to get 0.95. Oops. So we know that we're going into the tables with 0.05 on the left and 0.95 on the right. Okay, and we had, we're going to be looking for degrees of freedom 9. Okay, and the values that we come up with, according to the book, are chi-squared left is 16, excuse me, I've lost my place here. Chi-squared right is 3.325. And our chi-squared left is 16.919. I'm just going to go back here. I think I'm trying to balance the formula off with the values in the book. I'm just quickly going back and making sure I didn't transpose those, because that's very easy to do. And I should have also mentioned that our chi-squared tables are back on page 782. So we have 9 degrees of freedom. Okay, so 16.919, as I'm afraid I did, is, I just want to make sure my drawing matches these. This is no time for any confusion. So for 9 degrees of freedom at 0.05, we get 16.919, and then on the other side, we end up with 3.325. So the book has given us those. But I think they gave them to us backwards, if I'm not mistaken. Let me just go back and check that once again. Every once in a while they have an error. Okay, on the on the right side of the table, for 9 degrees of freedom, 16.919. Wait a minute. Yeah, 16.919 is on the right side of the table, and the left side of the table for 9 degrees of freedom is indeed the 0.95, 3.325. I think they've got those backwards in the book. Okay. Anyway, what we need to do is set the equation up, and we end up with, for our formula, which I'll write again here, n minus 1 s squared over chi-squared right n minus 1 s squared over chi-squared left. Okay. So we would have then 10, and again, it's just 9, but we'll write it like the book does. And remember, it's very important, we do not square the population, excuse me, the sample variance. We figured that out to be 16.9. I believe it was 16.9. Okay, and so on the other side we'd have 10 minus 1 times 16.9, and then both of these get divided by their respective values. Chi-squared right, we found out was, well, they've got those, I'm sure they've got those backwards there, but they didn't put them backwards in the formula, 16.919 and 3.325. Okay, and taking the book's word for the math, they end up with a variance between 45.74 and 8.99. And then, of course, what we're looking for is a standard deviation in almost all cases. So we would just root everything, and we would get the standard deviation. I'll bring it up to the top of the next page. Falls between 6.8 and 3.0. Okay. Well, I think that's a good place to stop. This should give you enough to understand how we get into the chi-squared tables and how we do the the two example questions I did. One of them, they gave us the standard deviation, and of course we had to square that when we used the formula. And the other one, they gave us the variance, the sample variance, and we did not need to square it. Okay, well, I'll be back shortly with some thoughts on section 8.1. Thank you.